You want us to introduce ourselves?
Hey man. So welcome to Channel 9.
Thanks.
I'm back in networking land and I've been doing some IPv6 stuff.
Right.
Who are you? Tell me your story.
I'm Mike Flasko. I'm the program manager for the Winsock team as well as the System.NET namespace in the .NET framework.
Outstanding.
I'm Anthony Jones. I'm a developer with the Winsock networking team.
All right, man. So what are we going to talk about today? You're the program manager.
Sure.
Guide us through this.
Sure. So today we're going to talk about how you go about writing applications for sort of the next generation of Windows platform which supports IPv6 natively.
Okay.
So what this means for application writers is that they now need to support IPv6 and IPv4. So this is sort of the core network protocol layer that people need to be looking at. And so what we're going to look at today is sort of some of the core APIs that people can be using, some of the new APIs in Windows Vista exposed through Winsock or System.NET that people can use to easily enable IPv6 in their applications.
Excellent. And of course Winsock for the unmanaged people and the other one for the managed people.
Right.
Cool. So that's important that we make that distinction because a lot of people writing code for Windows write unmanaged code.
Sure.
So they get to play with new things as well, which is very
Right.
important. So what is this stuff? Tell me about it. How does it work?
So it's, if you look at, traditionally Winsock applications, they usually create a socket, then they do name resolution, and then they go about connecting, right? So in order to make your application agnostic or not care about which IP version you're using, it's going to require some developers to change the way they write applications,
Okay.
as well as use a new API for name resolution that supports IPv6.
Okay.
Get host by name, which everybody uses,
Uh-huh.
to take a name and resolve it to addresses, only works for v4. So if your app does that, then you're stuck in v4 land forever.
So why couldn't I say get host name and have you guys return to me an IPv6 address? When I create a new method that would just do that for me, and you do.
Well, so get host by name, the structure that it returns to you are just 4 bytes long. So an IPv6 address is 16 bytes. So to enable all those new gadgets that can each have their own IPv6 address, you needed an addressing structure much longer.
Okay.
So they went from 4 bytes to 16.
Okay. Cool. So let's continue here. Talk to me. So I just got back from Spain, so I'm a little jet laggy, but this is very interesting.
Okay.
So we've already covered IPv6, the introduction.
Okay.
On the last episode of this little IPv6 series we're doing.
Okay.
So let's talk a little bit about what it means for developers now.
Sure.
You mentioned that they're going to have to. There's new
Change.
APIs. They
Yeah.
have to change things. So let's dig into this a little bit.
Sure. So maybe we can split it up and we'll talk about the managed space and then we'll talk about the native space.
Excellent.
I think that's an easy way to do it.
Cool.
In the managed space, the story is pretty good in that if you're working at the HTTP, WCF layer, FTP layer, most of this is abstracted away for you, and you don't have to worry about it. You continue to write the code like you've written, all along.
Okay.
If you're working at the socket layer, you need to make a few adjustments to enable IPv6 in your applications. Some of them aren't apparent up front, so there's a little bit of legwork that you need to do, but for the most part, there are a few tweaks to make this thing happen. When Anthony talks about the native space, he'll go over some of the socket options you need to set, some of the APIs you need to use. Since the System.NET namespace, at least at the socket layer, wraps the native Winsock APIs, most of the concepts that he'll talk about map directly into the managed code world, and that changes you make at the native layer are pretty much the same changes you need to make at the managed code layer.
Cool. Yeah. Now, are these pretty minor changes for the most part? Yeah, I know that's kind of a broad question to ask. But.
Well, the basic change that you need to make it v4 and v6 aware is just to use a different function to resolve the name, so that you could possibly get back for a name a number of IPv4 addresses as well as a number of v6 addresses. And that's the basic first step you need to do. The next thing you need to do is probably change the structure of your program. Instead of creating your socket first and then doing name resolution, because you never know if they're going to match, you should do the name resolution first and then actually create the socket of whatever address family you're actually going to try to connect to. So if you resolve a name and it gets you back 4 v6 addresses and 1 v4 address, the first socket you're going to try to create is a v6 socket.
Okay.
And that's the basic change. Now there's also a new feature with Vista
Yes.
that allows
Good.
dual mode or a dual stack socket.
Interesting.
So you could be V6 enabled in Windows XP and Windows Server 2003. It's just that the way that the stack was written on those OS releases, they're completely separate. So they share no data. If you want to do something with V6, that's one socket. If you want to do something with V4, that's creating another socket.
Okay.
But for Vista, the stack was rewritten. I don't know if they went over that in the
We can continue.
previous-
We should probably kind of keep hammering that.
Okay.
I don't think people quite realize how much incredible work has gone
Yeah.
into the network
So
stack.
there's a lot of work around sharing common layers. So TCP and UDP are a common layer that sit over a V4 or V6. Whereas before, there's a separate TCP and UDP layer for V4 and a separate TCP and UDP for V6. So now they share. It's much more elegant design,
Cool.
as well as enables better performance, as well as dual stack sockets. So this what allows you to do is create a single TCP or UDP socket, and it can then go over V4 or V6. So
Depending upon what, a flag or
yeah. So in this case, you create a V6 socket, and then there's a socket option you set. It's a IPv6 underscore V6 only. That's the option,
sure.
and you set it to false. And what that does is once you bind the socket, it goes and opens up an endpoint on both the V4 side and the V6 side. So whatever port you decided to bind to, say 5000, once you do set that flag and then call bind, it opens up an endpoint on each stack.
Nice.
So that way, if you get, say, this is a UDP socket, if somebody sends to you a packet from a V4 source to your destination on your V4 address on port 5000, your socket will pick that up. So that data will be delivered to you. Likewise, if you had a V6 endpoint send you some data to your port 5000 to your V6 address, you'll get that data as well. So using one endpoint, you can receive both V4 and V6 traffic.
That's incredible. That's awesome. Now, for the user, that means they don't have to worry about adjusting settings to be IPv6 compliant. I mean,
No.
let's talk about it. I saw there's some confusion I saw on Channel 9. Someone asked a question today regarding that. So clearly there's confusion out about, like, you turn IPv6 on to get it to work on Vista.
Nope,
This
it's
one's
on by default. So it's available by default. Your application has to take advantage of it.
Exactly.
And with dual stack sockets, the only thing that you have to do is create a V6 socket, set that flag, and then you're V4, V6 enabled.
That's excellent. Very
So-
cool.
I think the core thing to note there is that there's the dual stack socket support on Vista, but there's also V6 support on XP and 2K3. So if somebody wants to take advantage of V6 support in XP and 2K3, they do need to create two sockets, as Anthony sort of alluded to. So that means creating one V4 socket, one V6 socket, and listening on both of them. Because at present there isn't that dual stack or that dual mode socket support pre-Windows Vista.
Sure.
So that's sort of the core change that you need to think about when you're writing sort of down-level OSs versus Vista OSs.
Certainly.
Right. So we've touched on creating a socket and some of the kind of core changes you need to make. The additional benefit there is that there's been some functions added in Vista that nicely abstract a lot of those changes away. So if you're taking advantage of it and you're using these new functions on Vista, a lot of these changes that Anthony's talked about, you actually don't need to make if you switch over to these newer functions. Some examples of them are connect by name in the Winsock space. And so when you use that, basically what it'll do is you give it a host name. It resolves the host name to an IP address. That IP address could be a V4 address or a V6 address. The connect by name function will attempt to connect to a V4 or V6 address for you and give you back the connected socket when it's done. So really the application developer is abstracted from the fact that it's a V4 endpoint you're connecting to or a V6 endpoint. So that's sort of the ideal function that you'd be using is to move over to these connect by name or additional new functions.
And it contains all the logic to retry. So I mean, if you're the host name that you're connecting to, say it's not V6 enabled, but it does have V6 installed. So the process is a legacy application, listening on V4 only. Normally, if you wrote this yourself, you would resolve its host name. You get back 5 addresses. 4 of them would be V6, 1 of them would be V4. You'd connect. The first 4 would fail because that server is not listening on the V6 address.
Okay.
So you'd have to have a lot of logic in your application to get this to work with that particular scenario. What connect by name does is abstracts all that for you. You give it a host name, it does all the retry logic underneath, and once it succeeds, it returns to you that connection.
Outstanding.
So it makes a lot of that tricky logic of retrying out of the developer's hands, puts it into the low-level code, into an easy way that developers can access that.
Marvelous. So in a real sense, Vista, basically has made networking programming a couple layers more abstract,
Mm-hmm. Yep.
which is a
Sure.
wonderful thing.
Yep.
And now managed people can play in this world fully. Correct?
Yep.
I mean, is there
Pretty
anything that a managed person can't do in this new world that you've created?
No, so pretty much all of the V6 support is exposed through the managed APIs. Some of them isn't abstracted fully into the managed space.
Mm-hmm.
So an example might be if you create a dual mode socket, you have to cast a particular socket option integer into an enumeration value because it's not exposed through the enum. But really, that's a single line code changed and something that we'll work in on the next release to make it crystal clear there.
Good.
I think the other piece that we haven't really touched on is why would somebody care to support V6? I don't know if you guys touched on that in
We
previous...
did, but let's keep doing it.
Sure.
I mean, Michael went through nicely about why it's important,
Mhm.
and clearly, by making these, sort of ridiculously long identifiers, you're basically saying, look, it doesn't matter what these are anymore.
Right.
Sure.
Code takes care of that for you. Let the network-to-network constructs deal with the meaning. You
Right.
just write your code,
Right.
which is basically what we've been doing with managed code and everything else. So, absolutely, I mean, from your perspective, let's talk about why IPv6
Sure.
matters and what it means.
Sure. So at least from the developer perspective, kind of our guidance to them is, again, you don't really need to work or want to work at the network identifier level like the V6 or the V4 endpoint level. Instead, you want to work with host names, or now in Vista, PNRP, which stands for Pure Name Resolution Protocol. So basically, that's the idea of, hey, I resolve Microsoft.com. It doesn't really matter to me as an application developer if it resolved to a V4 endpoint or a V6 endpoint. I'm going to work at the the well-known host name layer, and then I'll let the application logic take care of choosing the right socket and whatnot. The same concept applies to peer-to-peer applications, and so there's a whole host of suite of peer-to-peer APIs that have come out in Vista that also support that same model of resolving a well-known name, and then I'll get back an endpoint, and my application really abstracts away from the end user, what those endpoints are, what type they are. So those are some of the advantages. In that
Definitely. I
particular
mean, one of the
area.
things, now that you mentioned that, I mean, in the first interview I did with Michael, I had mentioned, hey, Chess Titans comes to Vista, and it enables you to play with your friends. But in fact, no, it doesn't. It lets you play with yourself. It just switches the board
Sure.
around for you. So, in my sense, that's kind of disappointing. But that would be a perfect example of a really excellent use of this technology.
Sure.
So that two people playing on a built-in game on Vista, we could play chess like no matter wherever you happen
Right.
to be, in a different building, whatever. We have a peer-to-peer connection that we set up, and we just play chess.
I
I know
think
you can do that with MSN Messenger stuff, but
And I think you just touched on it there is, there's a whole breed of new applications that people are loving is the peer-to-peer based applications, right? In that, Anthony's got a great computer at home, I have a great computer at home, I want to play Halo with him. Is it easy for me to just connect to him and play Halo? In the V4 world, that's not so simple. Generally, we both sit behind home, routers or NATs.
yeah.
And that blocks us from really being able to do that, or at least being able to do it in an ad hoc fashion. Like I wake up and hey, now I want to play with Anthony, and we just
Totally.
can't do that, right? In V6, I think you've talked with Michael about Trado in the past. They have transition technologies like Trado that enable us to restore that end-to-end connectivity, so such that we can have these ad hoc scenarios. Like I wake up, I start up my app, I discover that Anthony's also online, and me from my house, I can connect to Anthony behind his home NAT at his house, and we can just play that game. So we're restoring those those true end-to-end scenarios that people have always envisioned that sort of went away when people started deploying the home NATs. And so, I guess we just touched on Trado, but we haven't really talked about, what does Trado mean to an application developer.
Yeah.
Again, Trado is just a transition technology that's applicable to V4, that's
Yeah.
part of V4.
So
And-
I hear that term a lot, transition technology. Let's talk about that. Vista Bridge, blah blah blah. I mean, you know what I mean. I mean, transition meaning we want to wean you away from the old habits and into the new world.
Right.
Right? Let's just say what it is. So if I'm programming
IPv4, Teredo server allows me to interact with other things as though I am IPv6, right? Sort of?
Well, yeah, so it is based on v6. So it's a way to have your v6 application talk to other v6 endpoints, but only have a v4 network in between.
Okay.
So this is the scenario where, well, the internet is only v4 enabled. It's not really v6 enabled. So how do two v6 endpoints talk to each other?
Yeah.
Well, Teredo is one of these things. If your host PC is v6 enabled, and Mike's PC, because we want to play Halo, is v6 enabled, Teredo allows me to connect to him with a global IPv6 address, but have the IPv4 infrastructure between us. And it gets through all the problems of me being behind my own NAT. So the v4 address that I have is not a publicly addressable one. You know, my NAT has the public IPv4 address.
Yeah.
Same thing was his. So Teredo will take care of all the underlying goo that is necessary for me to be able to connect to him with our IPv6 addresses through a v4 infrastructure. And if you wrote the application with, get attr info and all the IP agnostic APIs we've been talking to, your app doesn't have to do anything special.
It doesn't.
It doesn't.
Well, let's talk about that. I mean, so I must have to do something. No?
Well, the application has to do one thing. So there's a firewall exception because by default, Teredo basically encapsulates v6 and UDP.
Okay.
And most NATs and firewalls, or at least most NATs, let UDP traffic flow freely. So to protect the actual PC from maybe malicious data, there are some security measures enforced for Teredo. So once you have an application that you want to be able to communicate over Teredo, you do one of two things. There's an option in the firewall to enable edge traversal. So you can go into the UI and click, because you have to enable a port anyway for this application, that this application allows edge traversal. And what that'll allow is then Teredo traffic to flow freely.
Okay.
The other option is, if you know your application is going to work or want to run over Teredo, there's a firewall API, set firewall policy 2, that you can set to enable that. It is an admin API, so it'll give you the pop-up, the Lua pop-up.
And you could do this in your installer.
Yep.
Right? I mean, that'd be the smartest way to do it, not confuse the user anymore.
Yeah. So, aside from that, once you do that, then you're enabled with Teredo, and the application, other than that one manual setup or API call, then is a v6 app. It just works like a v6 app.
That's awesome. In an IB, in a 4 world.
Yep.
IPv4 world, which is great. Very cool.
Yeah, and so I guess the extension to that, and you asked the question earlier, is there anything that a managed code developer can't do that's exposed in native? And the one thing to watch out for is setting those firewall policies from managed code, and that there isn't a managed API for the on top of the native firewall APIs yet.
Okay.
So you would have to p-invoke if you want to set that Teredo edge traversal option programmatically. But the user could also set that via firewall UI or whoever what makes sense for your application. So I guess that is one area you'd want to look out for as a managed code developer.
Absolutely.
Definitely. Yeah.
Cool. So is there any whiteboard? Certainly looks white. So let's sketch out maybe a little bit how this works.
Okay.
And so some of the low level architecture and kind of keep with the developer in mind. Because you guys have done some fantastic work in rewriting the whole network stack. So the specific areas you can talk about. Let's draw pictures and talk about stuff.
Sure.
How's that sound? How's that for
Do
a
we want to
random?
go from maybe what a traditional application would be structured about today,
Sure.
over before, and then we'll maybe show what the difference is and to make
Cool.
it v6 enabled.
Yeah.
Just
I think that's cool, and it would also be cool to maybe show quickly how to take your existing app, and we have all the whole Vista compatibility stuff, and make it sing in the new networking world.
Sure.
But sure, let's
go for it.
Whiteboarding's fun.
All right. So, the traditional structure of most Winsock applications is you create the socket first, and then you do name resolution. So, you would usually see something like this. And because they don't know about v6, they usually hard code that is actually an IPv4 socket anyway.
Okay.
Let's say IP proto. So you create your socket, and then the next thing that they would do would be get host by name. And here you pass in whatever host that you're connecting to. So they do this. This would return to you a host entry structure, and from there they'd also assume that you only got one v4 address back.
Okay.
Right? And I mean, it's possible, even in v4, that an endpoint or host could have multiple IPv4 addresses, but applications pretty much assume you get one back.
And so let's just quickly, why is that the case? I mean, why can't I assume? I mean, an IP address, certainly a naive way to think about it is an IP address is a unique identifier for some thing that you can always guarantee is that thing. Now, DHCP kind of messes with that.
Yeah.
But talk to me. Why can I get 4 back?
Well, with v4, you usually only get one. I mean, v4 has the concept of a global address and then a private address. So the 192 or the 10 dot. I mean, those are private, non-routable addresses. And then pretty much everything else was a global address. So you really only needed one. There's very few scenarios where you'd have multiple IP addresses on a machine. Multi-homing was about the only case where you'd have maybe 2 NICs on 2 different networks. Then you may have 2 IPv4 addresses. But just historically, that was very rare unless you're in some sort of specialized environment. So most applications assumed you only had one.
Okay.
Right, and the one that you got back would always be globally reachable.
Okay.
Right. Well, with v6, v6 is a little different. It has different types of addresses. So there's addresses that are globally routable. There's addresses that are assigned to transition technologies like 6-to-4, ISOTAP, or Teredo. So those are different kinds of addresses, and they have different scopes. So the different scopes then mean different things. So that an application may try to attempt to connect over a globally reachable v6 address, or if it's trying to reach somebody that's not v6 enabled, it may be a transition v6 address. So you'll have an endpoint that has multiple v6 addresses now by default, pretty much.
Okay.
So that is, I mean, it switches the paradigm from where you only normally have an endpoint or host that has one address to one that'll always have multiple. So
Interesting.
that forces your application to take that into account, whereas in the past you didn't.
But you really don't need to worry about the specifics of those addresses,
No, you don't.
right?
No, you just need to know that when you resolve a host name now, you'll most likely get more than one address back.
Okay, excellent.
And you may not be able to reach that endpoint by all of the addresses.
Okay.
So, from here, the tradition was you got your address back and you do a connect. You connect your socket to whatever address was returned from here, whatever address that was. And then if that failed, then you bailed out, right? There was nothing left to do. If the address that they gave you, you couldn't connect to the host from that, then the app was done. Yeah, bad experience of using the wrong address.
Yeah.
To change this, though, it's pretty straightforward. Basically requires you to move your name resolution function before your socket creation call.
Okay.
And then you use a different function to resolve the name. So this is the IPv4 only stuff. This is the IP agnostic.
All right.
Here what we do is we do get adder info. You'd say foo. The nice thing about get adder info is it actually rolls in get host by name and get host by serve.
Okay.
Or get served by name, sorry. So get served by name, instead of a host name, it would resolve service names like FTP. So if you wanted to get the port that was associated with FTP, you call get served by name. And it returns U21. Well, here you can do it in one call. So not only are you resolving foo, whatever foo resolves to, but it'll also look up FTP and give you the port for that. There are hints if you want to control how this name resolution works. But by default, you don't need any hints. If you want to be IP agnostic, you can just pass a null.
Okay.
And what that'll do is it'll mean that I want v4 and v6. I want to be IP agnostic. Return to me whatever addresses you've got.
Okay.
Then it returns to you a linked list. So results. And that's a struct adder info. And from here, you basically just loop through this linked list, and each entry in that linked list contains an address, the address length, and some other information. And using those, then you can just go ahead and create sockets and call connect.
Excellent.
So in this case, pointer, we will iterate
Pointer.
through our result list.
This isn't C sharp.
This is C.
Kidding.
I don't do C sharp.
You don't, huh?
Mike's the C sharp guy.
We can convert it to real language.
So, we're just going to step through this linked list. AI next pointer is the next guy. It'll be null
Okay.
terminated. And then what we do is we create our socket. And all the information you need is contained in the adder info structure. So, oops. Yeah. Yeah, AI family. It'll tell you the family. If I could spell here. You can also, in the hints, you can specify whether or not this is a stream or a datagram socket, which plays an important part in the looking up of the service here, because some services have different port names depending on whether it's TCP or UDP. But that's just a side thing that wraps up for you. AI sock type and pointer. And you've created your socket.
Great.
And then all you need to do then is connect. If this is a connection-oriented socket anyway. It gives you the address, an AI adder, and it gives you the length, which is the other argument you need.
Mm-hmm. And what that tells you if it's V6 or V4?
Yeah, so these sock adder structures, V4 or V6 will tell you here,
Got it.
the family one.
That would be nice.
But this address length will be the correct length for whatever underlying sock adder this really is.
Okay.
So if this address is actually a V4 address, this adder here points to a sock adder in, which is 16 bytes in length total. And the address length here will be the equivalent 16 bytes. If this particular address is V6, then AI adder points to a sock adder in 6, which is 28 bytes, and this adder len will be the correct corresponding length from that.
Cool.
And there you go. It's really changing your name resolution call, and then taking into account that you may get one or more addresses back.
Okay. And
Yeah.
it doesn't matter if it's 4 or 6.
It really doesn't matter. I mean, in this code, you will see no reference to AFINet or AFINet 6, because you don't care.
True. Now let's say now if I were writing code that had to interact with another application or service that's expecting a V4, then I would use this information here,
You could.
right?
Or this will still work, right?
It will.
If the whatever you know that the server you're connecting to is only V4, this will still work, right? If the server does have V6 enabled, you might in your name resolution call get some V6 addresses back. The connect will fail, but then you'll move to the next one, and eventually you'll get to its V4 address, create a socket through V4, and your connect will succeed,
Got it.
right? If the server doesn't even have V6 installed, maybe it's an older operating system and they didn't even enable it, then your name resolution is only going to return V4 address anyway, and this code is just going to create a V4 socket and connect on that.
Excellent. Very cool. So it doesn't look like rocket science.
No, it's
Very
pretty straightforward.
nice.
The important part there is you're doing no new work, you're just reordering work you've already done. And actually, the code Anthony showed at the bottom there, the IP agnostic set of code, that would work on XP, that'll work on 2K3, that'll work on Vista.
This will actually work on Windows 95.
As well as Windows 95.
Well, so get adder info is a new function that was introduced in Windows XP. But in order to make it nice for developers so that they don't have to have a different binary or a different code base for XP if they need or Windows 98 or 95, since get adder info is not natively available there, if you know you need to run down level on an OS that doesn't natively support get adder info, in the top of your app, if you just do a pound include WSPI-API.h, this actually adds some code to your application such that it'll dynamically determine whether or not get adder info is natively available. If it is, then it will call the native version of that function to do name resolution. If it's not available, then it imports some code into your binary so that it tricks you out into thinking get adder info is available. But in reality, it's only doing IPv4 name resolution because that's all that's available on 9x is v4, and your code will just work. You'll just get back v4 addresses. You'll never get v6 addresses back.
Excellent. So now, what about? We released Vista, right? Yeah, it's out the door.
All right.
So what kind of Vista specific stuff can we talk about? I mean, I want to write a networking app that I light up on Vista, and I don't care if it works down level, which isn't always a good idea. Right. But let's pretend like I'm looking forward to the future.
Okay. So, well, we can look at the server side or the client side.
Before you jump on and erase your code, you might want to show, if I were to just target Vista, what would I have to do to write that same piece of IP agnostic code? So you'll see it boils down to pretty much one line.
You want to see this in Vista?
So I guess you can show you what it looks like on Vista.
All right, you can create a socket. Now let's erase this.
All right, we can remember that.
We remember that one. You can rewind.
All right.
All right. So you create a socket, and this is going to be a dual mode socket. So dual mode sockets are by default v6. You create your sockets. You set a socket option. So we're going to set IPv6 only to false or 0. And then you just call. So you just create the socket, set the socket option to false, and then connect by name replaces the code that we had there before. And connect by name, what it will do is it's going to resolve foo and FTP for you. It's also going to do an address sort. So there's a preferred ordering of addresses that are most likely to succeed. It sorts them, and then it's going to try to connect to each one one by one. And once it succeeds, it returns to you with success, and it returns to you also the source and destination addresses that were used on which that connection succeeded.
Excellent.
And then boom. That socket may be connecting over v4, or it may connect over v6. You shouldn't really care. You're connected. That's all you should really care about. But what it will do is it will return the address to you. If it is a v4 address that actually succeeded, that comes back as a mapped address that's mapped inside a v6 structure.
Cool.
But then again, an app shouldn't really care.
Yeah.
It's connected. That's what I wanted to do.
Yeah. Excellent. So let's, let's dig a little bit more into what this means exactly. I mean, I can see what's going on here from a making it easier point of view, making it agnostic, which is wonderful. Let's talk a little bit higher level as far as what this is going to enable in a new generation of. I mean, what is this protocol agnostic world kind of enabling?
What enables you to be sort of decoupled from the underlying network fabric that you're on. So in the future, that if IPv8 comes out, your app doesn't have to change. I mean, you write it once in a way that doesn't care about what underlying protocol you use.
Yeah.
I mean, you know that you want to use TCP or UDP because that gives you a certain type of semantics. But beyond that, you don't really care how it addresses the endpoint that you're getting to.
Yeah.
So once you do that, and then write this code once, you won't have to change it in the future if something new comes out.
That's excellent.
And it just works. It just works. That's
very cool. So that really is a phrase that has meaning.
Yes, it does.
It's not just a marketing phrase.
Pretty much.
Very cool.
To the managed code developers looking at that, what we can do is we can map that over to what that looks like in the managed space, maybe.
Sure, we have a lot of managed developers.
Add to what that looks like.
All right. Enter the managed code person.
Enter the managed code person. Okay.
That's great.
So, to map it over to managed code, the semantics, the thinking, the logic is all exactly the same. This maps one-to-one to the socket class. So you create a new instance of the socket class. The parameters are identical. Setting the socket option is is just a call on the socket class. So if you had a socket S, we're just going to say s.set socket option. And then all the parameters that Anthony have already shown, they're identical and they're exposed in managed code. The only difference is that the particular value, this guy right here, the IPv6 v6 only option, isn't exposed in the managed enumeration. So if you go looking for this in socket option name, go looking for IPv6 v6 only, it's not there.
Now, why?
Simply because it's something that's been enabled on Vista. Our last rev was Whidbey, which was pre-Vista, so we just haven't had a chance to expose it.
Fair enough.
But the great thing is that you can still use it. So what you end up doing is you end up passing, instead of an enumeration value, you just pass the number 27, and you cast it to,
which is in the Winsock header file.
socket.
You can look these things up.
I
And
think
find
it's
out the
option name.
Okay.
Yeah. And so, like Anthony said, it's in the Winsock header file, so it's not a number I just made up. You can trust me that it's the right number.
No, definitely. Got it.
And so once you've set the socket option, you can do connections just like Anthony's shown before, but it's s.connect instead of any other function that he's shown. And then you just pass your standard set of parameters. What Anthony was touching on before is that when you're doing this and you're working in a dual mode stack environment, the IP addresses that you work with might not look like what you're accustomed to, because typically you're accustomed to seeing like an IP address that's structured like 24.5.6.7 something,
Yeah.
in this format. When you're working with dual mode sockets, those are sockets that work with both v4 and v6. Obviously, you can't give a v4 specific interpretation, and again, so what you end up doing is you give a IPv4 mapped IPv6 address. So if you want to convert this over to something that's usable with the dual mode socket environment, all you end up doing is writing it in an IPv4 mapped form, which looks like this. So this is really an IPv6 address, but as you can see, the bottom 32-bit is just the v4 address that you want to go to. So you can take this guy and pass him directly into a connect call, and it'll just work.
Nice.
Yeah.
Very cool. So a lot of the magic is happening under the covers, which is really how it should be.
Right. So the stack sees that you've got a v6 dual mode socket, and then when it sees these mapped addresses, it'll know that this is actually goes over the v4 stack, and so it routes it appropriately. And your app, or the communication on the wire, actually goes out v4.
Cool.
But your app doesn't really care.
So now, you guys, have you always been working in networking? What got you psyched about working on the networking stack?
Well, I've been working in networking for 9.5 years.
Okay.
At Microsoft.
Cool. So you've seen a lot of good changes.
Yeah, I mean, I started back.
He is the book author.
Which one?
So I did write 2 books on this.
Yeah.
Nice.
It's
All
Anthony.
right. That's him.
That's me. Well, I mean, I started off in network developer support. So you would see the problems that people would run into. I mean, you'd see people doing get host by name, and they hard-coded v4, and the kind of problems that they'd get into. So when v6 came out, it was just really cool to see the applications, or the enable the application developer to sort of abstract all this stuff, and to do it with like just one call and not really care, what the underlying protocol is.
That's very cool. So what about you? What's your story? Well, I mean, it's important. I mean, this is the people behind the technology as much as it is the technology. So
I've been with the group about 2 years. Came from University of Victoria before that, so I just got interested in networking in that area, and then joined the group about 2 years ago, I think. Yeah.
Excellent.
And so I'm with the managed group and the native guys, so we get to see both sides of the technology space and evolve it in both ends.
Do you have good, nice debates back and forth?
He tries to convince me of the merits of managed code. I still don't believe him.
Excuse me. Sorry about
No
that.
problem.
See, that's the problem with cell phones. So you don't see the merits of managed code?
I just give him a hard
You
time
just
about it.
plan.
I see the merits. I mean, it's a nice way to get into networking. I mean,
Yeah.
some of the unmanaged Winsock code can be pretty intimidating.
Absolutely.
Get outer info, things like that abstracts it a little bit better. But there's still a certain curve that people have to get over before they really get comfortable with Winsock. Whereas, you can pick up the managed code stuff pretty easily and have a simple networking app running.
Totally. And it's C# and VB. Those are elegant languages.
Yeah.
They get the job done. C++ is live and strong. You're programming in C, right? Are you a C++ guy? Yeah.
It depends. Well, working at the OS level, most of the OS code is still C code. There's some C++. It kind of depends.
Yeah.
But yeah, most of the time I'm in C land.
Nice, man.
Yeah.
See, so they do still exist, everyone.
They're still
There's
here.
one right there.
The building's like full of them. Except for the
Excellent.
4th and 5th floor.
So we've rambled a lot about
Yeah.
porting to to an IP agnostic world, making your application IP agnostic. There are some tools out there to help you do it, help you catch some of the things in your code that might not be IP agnostic that you're not aware of.
Okay.
So in the SDK now, there's a tool called checkv4 that you can run against your source, and what that'll do is it'll flag a bunch of, if you're making a call that's IPv4 only and it can be replaced with a different one, it'll flag that and say, hey, I've noticed you're using this, here's a better alternative.
Mm-hmm.
Right now, there's no such tool in the managed space, but we're looking at extending the the FXCOP rules to enable that in the managed space. The other thing that I think is most beneficial here is just once you're writing to the IP agnostic world, just turn off v4 and give it a run.
Mm-hmm.
It should work exactly the same way, and that's really the only truly way to get down to testing. If you are truly IP agnostic, is turn off v4. And actually, in Vista, you can do that via the netsh command. So it's one command to disable, I think, and then you're
Okay. And then you
good
run
to
your
run in
code.
v6 only. Exactly. So I believe that's the first time that you can actually turn off v4 significantly. But
That's the first time you can really turn it off. Older OSs, you could unbind v4 from the adapter.
Mm-hmm.
So you could do that in XP or Win2K3. Although, since a lot of the system services in XP and Win2K3 were not written to take v6 into account, you'd see a bunch of random strange failures with services not working anymore.
Yeah.
But the other thing with Vista is almost all of the system services that run on the box are v6 enabled.
Excellent.
So they'll work whether or not you're on a v4 network or a v6 network.
That's very cool. So we're actually utilizing the work that you
Yep.
guys have done.
Oh yeah.
So have you seen any really cool applications that take advantage of this stuff?
yeah, if you look at the meeting space application on Windows Vista, have you played around with that?
I have not.
Okay.
I don't like going to meetings, so anything has a meeting in it.
That's
I turn it off.
understandable. That's understandable. The meeting space application is, entirely v6. The peer-to-peer framework is entirely v6. It relies on, the presence of v6 on machines to function.
Remote assistance.
Yeah, remote assistance. So the meeting space application essentially lets me start up an app, say, hey, I want to start a meeting. I want to invite Anthony. Anthony might be sitting at a coffee shop, at the local, coffee shop, and I can invite him, and I can project my desktop to him, and we can sort of have a collaborative experience through this application, wherever Anthony is, and it doesn't matter, if the infrastructure between us is v4 or what that is. The transition technologies will just take over in those cases.
Cool. So like Teredo server.
Yeah, very much, yeah.
That's right.
Yeah.
Very cool.
So that is kind of one of the coolest ones I've probably seen is meeting space.
My family loves remote assistance, so
Yeah.
wherever they are, I can log on to their
I'm sure you're
machine and
psyched,
help them.
Playing
Makes
your,
my
so
days even
yeah, when
better.
you're playing your friends and whatever the Halo game. Oh, I got to pause. I got to do a remote assistance job.
So I gotta help my mom out.
That's awesome. So excellent, you guys. This is great. Anything else you want to get out there to developers? They need to start getting their hands dirty on this soon.
Sure.
So where can they go and get really quickly up to date, up to speed, download some source code, start rocking and rolling? I'll link to it in Channel 9.
Sure. So we have a team blog, it's Windows Network Developer Platform blog, where we've actually started a series of posts about writing
Excellent.
IP agnostic code. There's also Microsoft.com whack IPv6.
Okay.
The next best source is probably the SDK. So there's a lot of good samples in there, and they've all been made IP agnostic for the most part.
So the Windows SDK, you can download that. It has the new socket options. So if you are trying to do dual mode, they're there. Like Mike said, the SDK samples, there's a Winsock section. There's samples in there that just do simple TCP and UDP that are dual stack capable.
Cool.
So there's a great place to start. And there's more advanced code in there as well.
Yep. So let's see here. Come on. Wow. I'm in an interview. It's actually, but anyway, I'm sorry. I'm not going to edit that, so that's going to be
Sweet.
in the video. But I wanted to ask you guys, it's an important question. You've rewritten the networking stack, and you've done work at a level that users just aren't going to see.
Sure.
All right, let's be honest. You've done core OS level work.
Right.
So, what are you most proud of, and what's the one thing that you'd love to say, hey, check this out, to your mom, that you think your mom could get? Or, maybe that's not a fair question, but I think it's a good one.
Well, I think it's just networking is, they've taken a lot of the manual setup and the knowledge people needed to know to set up their PC on a network out so that it just works again, right? I mean, I remember older OS releases having to, guide my brother and all that through setting up a network, how to connect, to their ISP or whatever. Well, with Vista, a lot of that stuff, that networking work is automatic, right? It detects where you are, what you're doing, and gets addresses, finds connectivity, and just works for you.
Excellent.
So it helps me out.
It just works, baby.
It just works, man.
Very cool. How about you?
I think one of the coolest things out there now is the peer-to-peer support that's in Vista. It's awesome. You can do things. You can easily write applications that say, hey, find everybody else that's out there. Once I found them, I can say, hey, does that computer have a version of this game that I want to play? And if they do, I can send them a network message, say invite them, and the app will start up on both sides, and we can just play that game together, and it doesn't matter where the two endpoints are.
That's
and
awesome.
that all of that is enabled by the awesome IPv6 work that's been done in Vista.
Right on. Endpoint agnostic networking.
There you go.
You guys rock, man. Thank you for your time.
Thank you.
I
Thank
appreciate
you,
it. And we're going to continue this IPv6 little series on Channel 9, get more
Great.
info out there to devs so they can start rocking and rolling on this. Great to meet you.
Great. Thank you.
Take care.
Thanks.
Bye.